Here's an update on my pulse motor. I've got 4 magnets on the rotor now, and using one of these little hall sensors out of a computer fan for the switching. Just that little chip there. The power's on all the time, and you need alternating magnets to make it switch from one side to the other, but apart from being a bit thirsty for power, it goes pretty well. I'll just get it going. I'll just put the taco on and see how many revs we're up to. When that says 200, the rotor's doing 3000 RPM. It'll wind up a little bit higher, but it's pretty slow going up past there. And right now, both outputs from a little chip are driving the coils, but with this little switch here, it's only power's only on half the time now, and the revs drop back to about 2,500 RPM when I do that. So the balance is a little bit tricky. I can muck around and pull it apart and have 10-20 goes at getting it to spin nicer, but I'm going to pull it down now and change the adjust the positioning of the two rotor arms to close them up at both ends, and that way I can conserve a lot of power because I can just have one channel on for a short time. So I'll stop this recording and then come back and make another clip of that. See you soon. Okay, I've closed the rotor up. It's not pretty, but I can get it to run a bit smoother like this. It balances up a little bit better. So I'll just try and show you the switching. You can see that I've got one channel switched off at the moment. It's only switching on one channel, but you can see that it's only on for a short duration and then off. So it helps conserve a lot of milliamps instead of having it. So with the rotor arms crossed up like I had it before, each output of a little chip there is on for 50% and off for 50%. With the rotor arms closed up now, it's on for 40 degrees and off for 140 degrees, so it helps conserve a bit of power. It's still doing up around 3000 RPM, but maybe not quite. We do get a bit of voltage sag in this old building through the day, so that might be all that is. I'll just have a bit of a look at the taco. No, it's still sitting on 3000 RPM. It just tends to loosen up a little bit over a few minutes and the bearings get a bit warmer or something. So you can see these little chips are pretty versatile. There's not much else required in the way of circuitry, and a lot of them are marked 276, 277 but probably no chance of reading that, but anyway. They can switch generally up to about 400 milliamps and take an input voltage of up to 16, sometimes 20 volts. So there's a fair bit going on in the chips there. They've got reverse polarity protection and then voltage regulation and several transistors and other things going on in there. So I was surprised to find there's actually a little bit of power consumption when they're not doing anything. Here I've got turn one channel off and stop the rotor and the LEDs out, so that you would assume that there's no power going through the chip, but that's actually about 17 milliamps sort of current drain there, just idling, not doing much. So if you're on a mission to conserve power and milliamps, it might not be the best switching for you. You might be better off with a reed switch and a transistor in that regard, but they're a pretty handy little gadget. I did actually try that one, and it draws 12 milliamps instead of 17. But I'm going to try a reed switch next, and try and conserve a little bit more power. But anyway, there you go. This